Welcome, folks. Today we're going to take a look at simplifying rational expressions by adding and subtracting with an uncommon denominator. Last time we had a common denominator. Look at these denominators here. On this do question, a squared minus 5a and a squared minus 25. Today, these two denominators are different. So we're going to take a look at how to add them when they have uncommon denominators. Before we begin today, I want you to start with a warm-up. In this question that I have right here, notice your denominators are the same. I'd like you to pause it for a moment and do this question. Now that you've worked through this question, let's see what you did here. Let's compare it with what you have on your paper. Okay, so to start out with here, you're going to take a look at the first one here, and you're going to notice that we have a common denominators, 3x minus 1, 3x minus 1. Okay, now, because we have common denominators, I can just add the numerators. So, in adding the numerators, the first thing that I need to do is I notice I have a negative here. So I'm going to distribute that negative to here, here, and here in the numerator. Alright, so when we do that, it will look like this right here. Alright, so we distribute that in, and then we start to simplify. So our solution will look as it shows right here. See, I've distributed this negative to each of the terms in the second polynomial. Here it is. Okay, now I'm going to add like terms. So we have 3x squared minus 2x squared, of course, gives us x squared. I have 3x, and there's no other, just 3x here. I have 2 and negative 5, which gives me negative 3. So my final answer is going to be x squared plus a 3x minus 3 all over x minus 1. Now, look up here in the directions. It says up here, express where the expression is undefined, which means you need to set this denominator right here equal to 0 and solve for it to find out where it's undefined. And it will be undefined at x equals 1/3. Today we're going to review just a little bit more, and we need to review the LCM, the least common multiple. Now, just to remember, to find the least common multiple, here's what you needed to do. Step number 1, you needed to factor each polynomial completely. For example, if I gave you x to the third plus 6x squared plus 9x, you could factor out an x, and then you'd have a perfect square trinomial giving you x times the quantity, x plus a 3, the quantity squared. Now, after you factor each polynomial completely, then you listed all the different factors. And if the polynomials had common factors, you use the highest, that's the key here, the highest power for each common factor. Now, why is it important to find the least common multiple? Well, the least common multiple is helpful when we add or subtract polynomials. Okay, so when we add or subtract rational expressions. Now, if I have a rational expression and they have unlike denominators, it is really important for us to find a common denominator, or I could say a least common denominator. The LCM will be that least common denominator. Alright, so let's give a few a try. On this slide, to find the least common multiple, you're going to factor each one of these. Now, all I'm going to do in this case is I'm going to break it up into different factors. So, if I have here 4x squared y cubed, that's going to break into 2 times 2 times x squared times y cubed. Now, if you want, you could put, instead of 2 times 2, just put 2 squared. Okay, for the second one here, we have a 6. Well, 6 breaks factors down into 2 times 3. So we're going to have 2 times 3 times x to the 4th times y to the 5th. Now, let's compare. The list of factors in this case, remember, we had a 2, we had a 3, we have a x, and we had a y. And we want the highest number of each. Well, looking right here, I have 2 2's here and 1 2 there, so I'm going to take 2 2's. Okay, here I have 1 3. I have no 3's, so I'm going to take 1 3. Here I have 2 x's. Here I have 4 x's, so I'm going to take 4 of them. Here I have 3 y's and 5 y's here, so I'm going to take 5 of them. So if you'll see the colors here, you're going to see we're going to take the reds, the blues, the greens, and the purples. We're going to list them out just like this. Now, let's clean this up a little bit. So I'm going to go ahead and I'm going to multiply this together. And in doing so, my least common multiple will give me 12x to the 4th, y to the 5th. Okay, you pause it, and I'd like you to do the second one. But notice on the second one, they're a little bit different. It's not like the first one. You have a polynomial here, so you're going to have to factor it into 2 linear factors. Okay, go ahead and pause it. Now that you have paused it and worked through this problem, let's go ahead and take a look at what you have. Well, looking at the first one here, you had to find the factors of -3 that gave me -2. So those are going to be -3 and 1. Okay, so the factor of that is going to look like x minus 3, x plus a 1. Now, for the second one, you had a -6, and the factors of -6 that will give me a -1 are -3 and 2. So that would be x minus 3, x plus a 2. Now, you needed to write down the different factors here. So let's see, I started with, I have an x minus 3, I have an x plus 1, and I have an x plus a 2. Alright, so let's take the largest number of each. So, of the x minus 3's, I have 1 there, I have 1 there, so we'll just take 1. For the x plus 1's, I have 1 here, I have none down here, so we'll take 1. And for the x plus 2's, I don't have any up here, but I have 1 here, so we'll just take the 1. So my LCM is going to be one of these, and one of these. So here's my LCM. Now let's put this idea together. And again, we're going to use the idea of finding the LCM of this denominator and this denominator, and that's going to become our common denominator, our least common denominator. So, we're going to start today with factoring this. So, when I factor that, that becomes, and I'm going to just kind of put it right down here. So the factors of -4 that gives me a 3 is going to be x minus 1, x plus a 4. Alright, now, compare here. To find my LCD, or let me just call it my LCM, to find my LCM, I'm going to look at each of the factors that I have. Okay, I have x minus 1 here. I don't have any here. So, I'm going to need x minus 1, one of them. Okay, over here I have 1x plus 4, I have 1x plus 4, so I'm going to need one more of those, x plus 4. Alright, now, this here is going to become my least common denominator. Okay, so, let me show the next step in the problem. So I'm going to uncover this here, and it shows the factorization of it. And so, now my least common multiple. Now, notice here, if my least common denominator is going to be x plus a 4, x minus a 1. Okay, so let me write that here as well. X plus 4, x minus 1. If my least common denominator is going to be these here, my LCM, notice here, what do I need to do to x plus 4, x minus 1 to make it x plus 4, x minus 1? Hopefully your response is, we don't need to do anything. It's already the same. Alright, so since we don't need to do anything, I'm going to bring the x minus 3 down. Okay, so let's go ahead and I'm just going to bring it down and put it right here. So x minus a 3. Now, in the second situation here, I have x plus a 4. I have x plus a 4. What am I missing between here and here? Well, hopefully you can see we're missing the x minus 1s. So what I'm going to do is I'm going to multiply by an x minus 1. But it's not good enough just to multiply by x minus 1. I have to multiply by x minus 1 over x minus 1. Now, the reason why I have to do that is because, notice, x minus 1 divided by x minus 1 is actually just a fancy way of writing a 1. It's a fancy way of writing 1. And the multiplication property of 1 says that I can multiply 1 by anything, doesn't matter what it is, and I'll get that same anything back. But instead of multiplying by 1, I'm going to multiply by a fancy one, like x minus 1 over x minus 1. Because what that does for me is it allows me to get a common denominator. Okay, so in doing this here, let's go ahead and I'm going to write this down, and we're going to have a 2x times your x minus a 1, just like that. Okay, now I have a common denominator here. So now we're back to the problems like we did yesterday. So I'm going to go ahead and combine the numerators. So in combining the numerators, and I'm going to write it over one denominator here, so that gives me x plus a 4 over x minus a 1. And on the top, I'm going to have x minus 3 plus 2x times x minus 1. And now I'm going to simplify that. So simplifying that a little bit here, I'm going to distribute my 2x into my binomial. And I will get, on top, I'm going to get x minus 3 plus 2x to the second power minus 2x all over x plus 4 times x minus 1. Alright, now, what next? Well, look to see if there's anything up here you can add together. Like, are there any like terms? Well, I have an x, and I have a negative 2x. And it also appears that I also need to get it in standard form, because I need to have my 2x squared first in order to get it in standard form. So let's rewrite it. So that gives me a 2x to the second power. And when I add the negative 2x and the 1 together, that's going to give me a negative x minus 3 all over top of, and I have an x plus a 4 and an x minus a 1. Now, we might be all finished, but we have to see something first. Is it possible, remember that very first day we started this in section 8.2, day 1? We had a problem similar to what we see right here, and we had to factor the numerator, factor the denominator, and see if anything divided out. Well, it turns out that's what we need to do here. So let's take this numerator, So 2x to the second minus x minus 3. And I'm going to see if I can factor that. So 2 times 1, 1 times 2, over here, negative 1 times 3, negative 3 times 1. And we're going to see if we can find anything here that gives us a negative 1. So let's see. It looks like this right here gives me a negative 1. So let's factor that. Let me move this up just a tad bit. Okay, so when I factor this, it's going to give me on the top, I'm going to get a 2x and a 1x minus 3 plus 1, and on the bottom I will have x plus a 4 and x minus a 1. Now compare this. Let's look. Is there anything up here that divides out with anything down there? And your answer is no, nothing will. So that tells me that I'm all finished. And this is my final answer. Now, it's just possible on a multiple choice test. Just to give you a little hint, if you ever take a multiple choice test on a question like this, your answer might look like this question, or like this part of it here, or it may have looked like this part of it here. Sometimes we have to change our answer into another form in order to find which answer choice is our solution. On a short answer test, I would accept this or this as the answer. One more thing here before we move on to the other slide. Let's go up and look at the directions here for a little bit here. It says up here, notice what it says. Identify any of the x values for which the expression is undefined. That tells me that when I'm all done, all the way down here, and I've added them together, it tells me I need to look at my final answer and see if it is undefined. Now notice I needed to do it before I divided anything out. And it just so happens that yes, I need to set this here equal to 0 and this equal to 0 and solve. So we're going to go x plus a 4 equal to 0, x minus 1 equals to 0, and I'm going to solve for each. And here I get x equals a negative 4, and here I will get x equals a 1. So to finalize this answer, to get my full answer the way the directions ask me to, I need to put a comma there, and say x not equal to negative 4 and x is not equal to a 1. Now we are completed and ready to go on to another problem for you to try. Okay, in example 2, you're going to see another problem, similar to the first. I want you to go ahead and pause this and see if you can work through it using the previous example as a pattern to follow. Now that you've worked through this, let's go ahead and work through this together. Okay, hopefully the first thing that you did is you factored this x squared minus 4. Now the x squared minus 4 factored into an x plus 2x minus 2 or an x minus 2x plus 2, whichever way. Then you need to define your LCM. Now notice here I have 1x plus 2, I have 1 here, and then I have an x minus 2, I have 1 here and none over here. So that means my least common multiple is going to be one of these and one of those. Okay, so here is my least common multiple. X plus a 2, x minus a 2. Now, let's compare here. Okay, so my least common multiple, here's my least common multiple right there for each one of these, in both of these. Now, what do I need to do here to get an x minus 2? Well, we have to multiply top and bottom by x minus 2. Alright, so here's what that's going to look like. We multiply top and bottom by x minus 2. Now that we've done that, now we are ready to simplify. So I'm going to distribute my x here into my x minus 2 and start cleaning up adding like terms. Alright, so in doing so, this is what it's going to look like. So I have just one LCM down here, or I'm sorry, one LCD down here, so I have x plus 2, x minus 2, and on the top, push this all together. Now we're going to distribute this in. Okay, so let's go ahead and let's do that here. So in working with this first one here, let's see, I distribute the x inside, so that gives me x to the second minus a 2x minus 8 all over top of x plus a 2 and x minus 2. Now, we think we might be done. However, is there something here? Could I factor this so it would give a common factor so I could divide it out down here? Well, we have to see. So first of all, let's just take this x squared minus a 2x minus an 8, and we have to come up with the factors of negative 8. That could possibly give us negative 2, and it looks like, there it is, right there. Okay, so this is going to factor into, let's see, on the top I'm going to get an x minus a 4 and an x plus a 2 all over, and I have an x plus a 2 and an x minus a 2. Alright, now, looking at this, let's see, is there anything that divides out? And yes, there is. You can see this x plus 2 divides out with this x plus 2, giving me simply, I have left an x minus 4 on the top, and on the bottom I have an x minus 2. Alright, now, we might be all done. Let's go up and look at the directions. Ooh, look at that. The directions do tell me where it's undefined. Okay, so we have to list where it's undefined. So let's go down here and let's tell us where it is undefined. Remember, we're going to set each of these denominators equal to 0 and solve. And at this point, if you can just look at it and you can see where it's not equal to 0, for example, you can maybe look in here and see, okay, negative 2 plus 2 is 0. So you know negative 2 is one of them. And you can look here and you say, oh, if I plug a positive 2 in there, that makes that 0. Okay, so that means 2 is also, x is not equal to negative 2 and 2. And our final answer is going to be this right here. Let's try one more. But in this one, I want you to see the difference. This time it says subtraction in there. Okay, now when you do an addition or a subtraction, you do it the same way. The only difference is when you combine like terms on the top, you have to distribute that negative first. Okay, go ahead and pause it. Now I want you to work through this one, and then we'll play with it together. Okay, and looking at this one, the first thing you need to do is you need to factor these denominators down here. This one you can't factor, but this one you can. Alright, so x squared minus a 9 is going to factor into x minus 3 and x plus a 3. Now, let's find the least common multiple between these, so we'll have our common denominator. So notice here, I have 1x minus 3, I have 1x plus 3, and I have 1x plus 3 there. That means my LCM is going to be x minus 3, x plus 3, so therefore my least common denominator will be x minus 3, x plus 3. Okay, with that in mind, let's look to see what I need. What am I going to need to do to this in order to get x minus 3, x plus 3? Well, I'm missing an x minus 3. So I'm going to multiply top and bottom by x minus 3. Alright, now we're ready to combine these. So I can put it all together. Okay, so here's what it's going to look like when I put it all together. Under one, or over one common denominator. Now, right here we're going to have to multiply this together and then distribute the negative in. So in doing so, let's move this block here. Notice first of all I've multiplied these two binomials together to get x squared plus a 2x minus 15. Now I'm going to need to distribute this negative inside. So if I distribute that negative inside, distribute it to each one of these, I will get over here, let's see here, I'm going to get 2x to the second minus 30 minus x to the second minus a 2x plus a 15. Now, here, make sure you have to distribute that negative to all three terms. So don't forget to do that. And that's going to be over top of the x minus 3, x plus 3. Alright, let's go ahead and let's add like terms on top. Is there any like terms on top? Well, let's see. I have a 2x squared and a negative x squared. So those are like terms. So let's go ahead and combine those. So that gives me x squared. Now, anything else? Well, let's see. I have a negative 2x, and that's it. So let's write down minus 2x. And I have a negative 30 here, and I have a positive 15. So that's going to be minus 15 over top of x minus 3, x plus 3. Am I done? Well, I don't know. I don't think so. Might be, but I don't know. If we look right here, I can factor this. So let's go ahead and factor that. So let's see. We have an x squared minus a 2x minus 15. And if you are getting good enough just to see it and write it down, do it, you know. If not, go ahead and do like what I'm showing here. So let's see, I see a negative 5 times 3, negative 3 times 5, and then negative 1 and 15 and so on. But it looks like this one is going to be it right there. So over here, I'm going to go x minus a 5, x plus a 3, all over, and x minus 3, x plus 3. Okay, is there anything that divides out? Well, looks like this x plus 3 divides out. Alright, so that leaves me with, for a final answer, I have x minus 5 over x minus a 3. Now, before we walk away from this, let's go back and look to see if it asks us to find where it's undefined. Look at that. It says, where is it undefined? So, we need to do that. So let's go back up here. And we are going to set each of these denominators right here and here equal to a 0 and solve. Okay, so let's go ahead and do that. So I'm going to set x minus 3 equals to 0, x plus a 3 equal to 0. Solve for it, and again, if you don't need to write this out because you can just look at it and you can see that if you add a 3 to both sides, you get a 3. Excuse me. Then go ahead and do that. So you have x is equal to a, or not equal to a 3. And over here, you have x is equal to a negative 3. So over here, x is not equal to a negative 3. All right. Well, that wraps up today's lesson for today. Let's take a look at the homework that you're going to be playing with next class period. Okay, for next class period, I've given you just a couple problems. You have 6 problems that you're going to be playing with. So, come to class tomorrow. Make sure you write this down so it's all written down, ready to go for tomorrow. And also remember, guys, we are going to have a quiz. So please make sure that you're prepared for that quiz. And remember that quiz. And let me write that down here. Remember, we have a quiz when you walk in tomorrow. Okay, and that quiz is going to be over section 8-2, day 1, 8-2, day 2, and 8-3, day 1. Okay, I'll see you tomorrow.